problem A says log base 5 of 5 to the first, doesn't it? So what's the answer? 1. Yep, the answer is 1. Because the log base b of e to the x is x. So the log base 5 of 5 to the first is 1. There's no work to show, there's nothing to do. It's a property you memorize, and then you can do all these problems. So what about B? No. It's the log base 4 of 4 squared, isn't it? Isn't 16 4 squared? So what's the log base 4 of 4 squared? 2. The answer is 2. Now C, same thing. You have to remember that ln is log base e. So what's the answer? ln is the same as log base e. Write it as log base e if that helps you. Log base e of e to the 10th is 10. I want to also remind you that I told you earlier what happens when you have an ln and an e touching each other.
Cancel out.
Yep, so the answer is 10, no matter how you think about it. All right, next one. ln e to the 1/3. Radicals do not live in logarithm land. So when you have a logarithmic expression with a radical, you are going to change that radical into a fractional exponent. So the cube root is to the 1/3 power. Right? You know that. You're supposed to know this already. So what's the answer to the question? 1/3. Easy, easy, easy. Now, E and F look a little different, so I'm going to skip those and go down to G. We'll come back and get them. I'm doing all the ones that are set up like this. Now, forget this for a second. What's that? 1. What's the answer to the question? 4 times 1 or 4. Yep. What about H? It looks different, but again, don't we have an E and an ln touching each other?
Yes.
So what's the answer? 6. Now, I is a little bit tricky. I really want this to be an 8, right? 8 to what power would be the same as 1? 0. Isn't this 1 right here, guys? Isn't that 1? So the answer to the problem is 0. Now, that should not be anything strange to you, because if you think back to your BFFs, this was your logarithmic picture, and this was the point 1 comma 0. So when you take the log of 1, you get 0 every time. The log of 1 is always going to be 0, because something to the 0 is 1. So the answer to that problem is, problem I, the answer is 0. All right, what about J? Anybody figure it out now? 1/2, perfect. Why is it 1/2? It becomes the log base 7 of 7 to the 1/2. Remember, a radical, you can't have a radical. You got to rewrite it as an exponent. So a square root will be a 1/2 power. What about K? Be careful. Remember, log by itself means base 10. There's an understood base 10 on that problem. So what's the log base 10 of 100? 2. Because isn't 100 10 squared? Right? Okay, what about this one? The log base 3 of 1/9. Is 1/9 a power of 3? Yeah? What power of 3 would it be? No, it's not 1/3. 3 to the 1/3 would be the cube root of 3. That's not what we want. How do we get 1 over?
-9.
Well, it's a negative exponent, right? And isn't 9 3 squared? So won't this be 3 to the -2nd? Gotta have your thinking caps on. It's not hard, but you gotta think. So what's the answer to that problem? -2. What about M? What power is a cube root? 1/3. So the answer is 1/3. Now be careful. We don't have an ln and an e touching each other in this problem. We have 1 over e cubed. Can we write 1 over e cubed as a plain e? What power would that go to equal 1 over e cubed? -3. Yep, exactly. So the answer is -3. Perfect. All right, we've done a couple of these now. Can you figure out O? What power of 4 is 1/16? -2. So the answer is -2. Very good. Guys, you gotta remember 1 over means a negative exponent. Okay, we'll come back to P. Q. Remember the base on that is 10. When you don't see a base, it's 10. What's the answer to that question? 3. Because 1,000 is 10 cubed. So the answer is 3. 3. Okay, we did one like R a little bit ago. Let's just look at the logarithm part of R. What's this equal? 2, because this is the log base 3 of 3 squared, right? So this is 2. What are we doing with that 2? Timesing it by a 2. So the answer is 4. Next one's exactly the same. What's the log base 2 of 8? The log base 2 of 8 will be 3, won't it? And what are we doing with that 3? We're timesing it by 3. So the answer is 9. And what do you think about T? 4. Yep, E and ln are directly touching each other. There's nothing in the way like a radical sign or a fraction if they're just absolutely touching each other. Okay, so that leaves us with a couple of odd log problems, like E and F, and what was the other one? P. And I went ahead and when I wrote down P, I put my base of 10 in there. Now, if you just looked at this problem and you had to take a guess, you just had to take a guess what the answer was. Anybody want to take a guess? What do you think the answer to this problem is? 10. 10. That's right. When these numbers match, that's the answer. It's another one of those properties of logarithms. Very, very simple. No work. It's fact. So these match, so the answer to that one is 2. These match, and the answer to that one is 7. These problems you can click right through if you remember the rules. So that's the big rule, and this is kind of an offshoot here. All right? So I'm going to erase that big red thing. That big red thing is something that you absolutely need to know. Okay, so you've got that written down. Because now I'm going to give you something else you absolutely need to know. And that's how we're going to do the problems in part 2. All right. Here's what we need to know. These two statements are equivalent. When you have an equation, notice this is an equation now. When you have an equation, it's a logarithmic equation, you can translate it into an exponential equation by doing what we call, well, what Mr. Miller calls loop-de-loop. B to the n equals x. So you make like a big loop there. B to the n equals x. So when I look at problem A, and again, I am not ashamed to slip that 10 in there. That base is 10, and it helps me to see it. So if I loop-de-loo that, what does this say? 10 to the third equals x. So the answer to the question is 1,000. So easy. Solving logarithmic equations, so easy. You just have to remember this. All right, next one, same thing. We put a 10 in there. What's that one going to say? 10 to the negative first equals x, which is 1/10. Yeah, we want to write that as 1/10. 10 to the negative first, 1/10. What about C? 10 to the negative second is x. So we'll put in the answer blank 1 over 100, 1 over 10 squared. Now, when it's an ln, it doesn't change anything. Notice, kids, I said log base b. That's any base. This works for any base. So if you happen to have an ln, then your base is just going to be e. Right? Remember, ln is log base e. So if it helps you to write it as log base e, write it that way. Then when you loop-de-loo it, what does it say? E to the fourth equals x. And that's the answer, e to the fourth. If we absolutely had to have a decimal, we'd go to our calculator and type in e to the fourth. But it's generally just fine to leave it as e to the fourth. What do you think about e? Won't it be e to the sixth, kids? Isn't it exactly the same problem? It's just a 6 instead of a 4. So the answer to e is e to the sixth. Now, if you're going to loop-de-loo, you can't have anything out in front. So any ideas what we might do? Remember, this is an equation now. This is an equation. What do you think we might do?
Divide 3.
Divide by 3. perfectly legitimate to divide by 3. So then we have log x equals 1. What's the base here?
10.
So when I do, it says 10 to the first equals x, so x equals 10. Easy. All right, what are we going to do with G? You cannot loop-de-loo if there's a number in front. So we're going to have to take care of that number. So ln x equals -2. What's ln stand for?
Log E.
Log base e. So e to the -2 equals x. And that's the same as 1 over e squared. We generally don't like negative exponents, so we'll look at 1 over e squared. Okay, try h. Tell me what you come up with for h. What did you get for h? 10 to the 1/2. And what's another way of writing 10 to the 1/2?
10 squared.
Not 10 squared. The square root
That's
of
what I meant.
10. The square root of 10. Remember, negative exponents mean 1 over. Fractional exponents mean radicals. All right, what about I? Ten to the 1/3 equals x. What's another way of writing 10 to the 1/3?
Cube root of
10.
x.
Perfect. Be careful on the next one. It's an ln. So ln x equals 1/4. Remember, your base here is e. So e to the 1/4 equals x. What's another way of writing e to the 1/4? The 4th root of e. Okay? Now, there is one thing I want to talk about in terms of some homework that I've gotten in. I'm going to turn back these quickly, and we're going to talk about a couple of things that we seem to be confused about. everybody's got them. Here it is. All right, so the one I want to look at in particular is the end behavior question. Okay, guys? I want everybody to look at problem number 3. I'm not sure if anybody got it right. Okay? Which means I did a sucky job of teaching it, which means I'm going to do it again, and then it's on you. Alright? So, first thing I'm going to do is draw a picture, quick sketch, of my function, which is this. And nobody should be talking. All of us are listening because we don't know what we're doing. So we're paying attention. You will see this question again. Alright, so what does this look like? Well, many of you said decay. Which it is decay, absolutely, that doesn't answer the question, but it definitely is a decay problem. So the picture of it would look like this. Like all exponentials, it has an asymptote at 0 and goes through to 0.01. And this one's decreasing because that number is less than 1. Now, the way we write end behavior, this is not negotiable. This is a pre-calculus class. So we are going to write it like we do in calculus. So whatever you did in the past when you were a little kid, whatever somebody else told you to do in Learning Commons or somewhere else, no. This is the way we're doing it. The limit as x approaches infinity of our function, the limit as x approaches negative infinity of our function. Now, if you rearrange things, you write them above, below, it's wrong. This is the way you write it. So get in the habit, write it 6 or 7 times just to make sure. The limit as x approaches infinity, and the limit as x approaches negative infinity. Now, all that means is, as I look at my picture, if x is approaching infinity, that means that way, right? So as I go that way on my picture, what is my pencil doing? Getting closer to 0 from the top. Very good. That is exactly what's happening. It's coming down to 0. Now, what's happening on the other side? On this side, it's not getting closer to anything, it's shooting that off, right, up into space. So we'll say infinity. It's going up to infinity. So that's what we mean by end behavior. What happens that way and what happens this way. Okay? Another thing I noticed when I was looking over these papers is the very last problem. How many organisms will be present after 6 seconds? Should we say blah, 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 0.42? How many organisms will be present? Have you ever seen 0.42 of an amoeba? No. You have one amoeba or you have 2 amoebas. You don't have fractional parts of amoebas. So we're going to round that off to the nearest whole amoeba. Okay? Not a huge deal, but let's just think about it. Okay? And then the last thing I want to comment on is when you are asked for the asymptotes of a logistic function, which you were in problem 4, what are the asymptotes? How many asymptotes does a logistic function have? 2. You need to have 2 asymptotes there. Every logistic function is going to have 2 asymptotes. Now, an exponential will only have 1, but a logistic is going to have 2. Where's the bottom one? 0. Right, well, 0. Where's the top one?
Limit.
Whatever the limit to growth is, which in this case is 16. Okay, you got it? All right, homework 3.2 and 3.3 will be due on Friday. So both those assignments are going to be due on Friday, okay? And whenever I see you again, we're going to crank out 3.4, hopefully.